Okay, so first question. So first question is for 2 mark and it is very simple for definition. So what will be the answer for the first part?
State Newton's law of gravitational gravitation.
So if you remember the statement that we discuss in gravitational law, gravitation law. So this is the statement: the gravitational force between 2 points masses is proportional to the product of their masses, right?
Yes.
Okay. So in first question, you just need to write the definition. We already know about that, so we are not going to write that again, right? And you can see this time definition is for 2 mark. And in part B, the planet Neptune has 8 moons. It means satellite. And each moon orbits Neptune in a circular path of radius r and time t. And equation is already given, right? So this time equation is already given. And g is the gravitational constant and mn is the mass of the Neptune. So what you need to assume that Neptune and each moon behave as a point mass, show that R and T are related by expression this. So you need to drive the equation till this point. So any idea how to start the derivation? Because if you want the reference, so that reference is in your first part of the question. They just ask you about the Newton's law of gravitation, right? So with the reference of law of gravitation, you got the basic idea that we need to start from the gravitational law, right?
Yes.
So you know the basic formula F equals to G m1 m2 over r square. So one mass will be the mass of the Neptune and the second mass is for the mass of the moon, right?
Yes.
So starting from the basics, we need to write the law first. And one mass is mass of Neptune and second mass will be the mass of the moon, that is a small m, right?
Yes.
Over r square, because this time we need to solve the derivations also. And if you remember one thing, that we are talking about the circular motion also, because moon starts to revolve around the Neptune planet, right? So this is our first equation. And we know that centripetal force is also equals to mr omega square, right? So basically both forces are equal and both will support each other, both will be equal and opposite. So we can say that the gravitational force is equal and opposite to the centripetal force, right? So both values will be equal and opposite, right? Or you may also write v square over r. We can also make the reference from that. Okay. And if we want to substitute the value of v, so the value of v is actually equals to Now you can see that both chapters are interconnected, right? So that's why you need to have a reference from first chapter also. So V is equals to 2 pi r over capital T, right? And if we substitute the value, and this r will cancel out this r, and now we can just simply substitute the value of V. Okay, because we know that from the equation we are getting pi value over there, 4 value over there. So that's why we use the concept of mv square over r, because from the first formula we are not going to get the same value. We need to write the numbers pi value over there. So that's why we take the reference from the mv square over r formula. Okay,
Okay.
this mass will also cancel out the other mass. Now we know that on left hand side we are having gmn, and this r square will multiply on the other side. So you will get 4 pi r square multiply by another r square divided by t square. Sorry, 1 r over there, because we cancel out 1 r over here. So now your final equation, you will get the same equation, right? Clear?
Yes.
So in this way you can see that we are again take the same reference, only need to substitute the value of v. Now the next part is there is a data for the moon Triton that orbits Neptune, and for the moon Oberon that orbits the planet Uranus. So basically there is a concept of two different moons for the planet. Now their values are given. Let's see what they are asking about, because they will ask about some calculation. That's why they just give you the value over there. Yes. So basically you need to find out the to determine the ratio for the mass of Neptune by the mass of Uranus, right? So their radius and time period is given, right? Their mass is not given in the question. So we need to find out the mass by ourselves. Okay. Any idea how to find out their masses and then their ratio?
We will use the above equation.
Yes. So because you know that your question is interconnected, so one by one you are connecting your previous part with the next part. So because in previous equation you observed that radius and time period was there, we only need to find out the value of m. So let's suppose if we first find for the Neptune, so your mass will be equals to g into t square, right?
Yes.
4 is the number, pi is equals to 3.142, and the time for the Neptune is 5.9. And the value of capital G is constant, that will also given in your the data book.
Well, why did you write 5.9? Shouldn't it be 3.5? We're not,
Okay,
uh,
sorry, that is for the time period. This is the value of time. So it is 3.55 cube, then 6.67 exponent minus 11. Then we need to write 5.9. So now you already got the concept how to find out their masses from the above equation. So you just find the mass of Neptune and then the mass of Uranus, and then you just need to substitute the value of their masses and divide them, and you will get the ratio. Okay.
Okay.
So this is the value of mass of Neptune, and your value of Uranus will be something, and then you need to divide your values, and finally you will get the answer. Okay. I am just writing the answer because I will share the marking scheme with you. So you can just simply compare the answer with the original one, right?
Yes.
So you can see questions are not much very difficult because mostly they are related to the calculation part. Second one is the earth may be considered to be a uniform sphere and the radius of the earth is given. And mass is also given, concentrated at the center. The earth is spin on its axis with a period of 24 hours. So this is the time period. A stone of mass 2.50 kg rests on the earth's surface at the equator. So now we are having an other mass, right? Now you need to use law of gravitation to find out the gravitational force of the stone. So I think that is very simple. Okay. So which formula will help us to find out the value of F?
Um, GM1 minus GM2.
Basically, they just write in the question that you need to use Newton's law of gravitation, the same law. F equals to G m1 m2 over r squared, right?
Yes.
So this is the law. Because in question it is already written over there, so you just need to substitute the value. You may take this value as mass 1, it's up to you, and this value as mass 2. Both values are in kg already converted, and radius is already there. So you just need to substitute the values and find out the answer. Okay.
Okay.
Just for reference, I am writing the answer because that answer might help you in the next part. Okay. Because first part is very simple. Now the second part is determine the force required to maintain the stone in its circular path. So now they are asking about the force required to maintain the stone in its circular path. So which force help us to maintain the body in a circular path?
Centripetal.
Centripetal force, right? And you know the formula again. So force is already calculated over there in the first part, right? And mass is also given. Only there is a problem of the velocity, right?
Yes.
So what we need to do? There is a time period given. And if you remember the last question, we just replace V by 2 pi R over T. Okay. So again, we need to do the same thing. Mass is given. They are talking about the stone. So we take the mass of a stone, and velocity will be equals to 2 pi r over capital T, right? So 2.5 multiplied by 2 pi value of r, because there is a square on it, and divided by the time period. Okay.
Okay.
So you can just simply use the time period. There is a time of 24 hours, and you need to convert into seconds. So you need to multiply it by 3600. So that will give your answer into seconds. Clear?
Yes.
So now you can easily identify and find out the final value. Okay. And your final answer will be equals to. And in next part, it is written the stone is now hung from a Newton meter. Newton meter gives you the value in Newton. Use your answer in part 1 to determine the reading on the meter. Give your answer to 3 significant figures. So basically in part 1, we are getting value 24.6. Okay. And we need to
Yes.
subtract from the second force. Why? Because we know that both are opposite, right? So what we need to do, we need to subtract the value. So the first reading is 24.6 minus 0.0842. So if you just subtract the value, so whatever you are answer getting over there, you need to convert into 3 significant figures, right?
Yes.
Okay. So if you just subtract the value, you will get the answer. Then you need to convert into 3 significant figures. Okay. Any confusion?
No.
So in this way, you have to solve your questions related to gravitation and the concept of the circular motion, right?
Yes.